Thank you for being part of Dr. Emanuel's lecture number 22. We're dealing with polar, cylindrical, spherical coordinate systems, Cartesian coordinate system. We just explained how we have gone about looking at it and finding out some of the boundaries. Okay, so we was able to find the boundaries now. And so the boundaries does not change, and we have to multiply times dv. And dv is r squared sine of theta times r dr d theta dv. Okay, so with this, we're able to separate them and be able to put the dv. We can do first the d theta, sine theta. We can do an r and a dr. We can also do. So what we have when we actually perform this function, we're able to come up with the zero, the lower limit dropped out. We have 2 pi, and we have the integral of sine is a negative cosine, going from 0 to pi over 4, and the integral of r squared is 1/3 r cubed from 0 to 2. So we'll plug in for pi over 4 minus pi over cosine pi over 4 plus, because it's a minus a minus gives a plus at 0, and since cosine is 1 at 0, we have to keep that. And we see that we have 1/3 and 2 raised to the cube power. 2 raised to the cube power is 8. 8 times 2 is 16 pi, and we have over 3. So this is our constant that'll stay out front. Now what we have is we have a negative 1 over the square root of 2. We want to remove the square root of 2 off the bottom immediately. So we multiply by square root of 2 over square root of 2 plus 1 for the cosine of 0. And we still keep the 16 pi over 3 out front. And now we want to get a common denominator. So to get our common denominator, we have to multiply by 2 over 2. And what we have here is with our common denominator, our 2 and our 16 should cancel, get 8 pi over 3 times the quantity 2 minus the square root of 2. So V is equal to our volume equal to 8 pi over 3 times the quantity 2 minus the square root of 2. So we're around 4 or 5 minutes in, so let's keep going. Let's see, because we want to find the centroid. Okay, to find it's symmetrical. So since it's symmetrical around x and y, it will start off with at 0 for x and for y. So what we have to do is solve for, guess what, z. So let's see what the z component is. The same limits are the same. We're multiplying it. We have to divide by 1 over the voltage, and we multiply the dv by z, and dv is r squared times sine theta dr d theta d phi. And when we substitute for z, r times the cosine of theta, get r cubed sine theta cosine theta dr d theta d phi. Now we're going to separate them so that we can divide, so we can integrate easily. So this will drop off. So we just get 2 pi come out front divided by v. We have here our 1 over our sine cosine d theta. We have to integrate that. We separated it, and we also have to integrate our r cubed dr. So what we have here we keep out our 2 pi r, and sine squared cosine theta times cosine theta is equal to 1/2 sine squared theta, as it goes from 0 to pi over 4. And our RQ dr is equal to 1/4 times the r raised to the 4th power, and the limit at 0 goes out, and we have it to the 2nd power. So 2 to the 4th power is equal to 8. 8 times 2 is 16. Okay. 2, 4, 6, 8. So if we have 8 here, we're dividing by what? 1/4. Okay. So that'll give us a 2 that can come out. So that'll be 4 pi v. And we have for our sine, and these will cancel. For our sine squared theta, or 45 degrees, that gives us 4 pi 1 over the square root of 2 squared. Square this, you get 1/2. So basically what we have here, the 1/2 will cancel out with that, so we'll get 2 pi over 1 over v. So we know what v is, and we're going to take the inverse of v, and that's going to give us 2 pi times 3 times 8 divided by 8 pi times the quantity 2 minus the square root of 2. So we have our v here. Our pi's will cancel, and we see the 2 and the 8, we left for 4 on the bottom. And we're going to multiply times its additive, it's multiple, and that will give us, if one is negative and the other one needs to be positive. If it's 2 minus the square root of 2, it has to be 2 plus square root of 2. Multiplying it times the top and bottom so that we don't change anything. That still is 1. That gives us 8 on our denominator. And on top we have 3 times the square, 3 times the quantity 2 times square root of 2. So we have z is equal to 1.28033. So that's where it is going to be with the centroid of this mass at x equals 0 and y equals 0. Okay, we're going to come back for one more problem that we're going to work through, because we're around 8-9 minutes in. Thank you.